In this video, we're finding a volume of revolution. So we're told the region bounded by y equals x to the fifth, that's the yellow curve down below on 0 to 1, and the line y equals 1, which puts an upper limit on this thing, and the y-axis. That region is rotated around the y-axis to form a solid of revolution. And we want to use disks to set up and compute the volume of the solid, and I've already supplied a volume element here, in other words, a thin disk. So we can identify the location of this disk by its right-hand end, and I'll just call that a variable point of x. That means the disk has a radius of x. And the thickness of the disk, that happens in the y direction, so we're going to call that dy. So next we're going to write down the volume contribution of this thin disk, and that's an incremental or infinitesimal dv, and that's equal to the area of the surface multiplied by the thickness, and that's a pi x squared times dy. And this causes a practical issue. We have a mixture of two variables in this expression. If we're going to integrate this, we need to get it all in terms of one variable. So the key to this is to figure out the y value corresponding to that x value. And the relationship there is given by the equation of the curve. Y is equal to x to the fifth, and that means x is equal to y to the 1/5. So dv can be rewritten as pi times y to the 1/5 all squared, that's y to the 2/5, times dy. Now we're ready to add up all the volume contributions to get the total volume. So the total volume is the sum of the dv's. Each dv is a pi y to the 2/5 dy, and we're adding all these up as y goes all the way from 0, that's a really tiny disk all the way at the bottom, all the way up to the terminating value of y equals 1, that's where the top of this solid cuts off. And to get the antiderivative here, I add 1 to the exponent on y, that gives me a y to the 7/5. And then I divide by that number, which gives me a 5/7 out in front. I then evaluate as y goes from 0 to 1. Notice that when I plug in the lower limit, this expression vanishes. The only survivor there is the upper limit. And when I plug in y equals 1, I end up with a 5 pi over 7. And that's our volume, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.